Hello, and we are going to talk about uh, Zeroth law of thermodynamics. Now, there are basically four laws of thermodynamics, and Zeroth law is actually the first law of thermodynamics. Now, sounds strange, right? The four laws are Zeroth, first, second, and third. There are basically four laws naming zeroth, first, second, and third. Now, in this video, we are simply going to focus our discussion on zeroth law. And before I get started with zeroth law, we will understand the natural tendency of the universe to attain more stability, and the universe always tends to reach to the equilibrium. Uh, Let me give you some couple of examples to demonstrate what I mean to say exactly. Consider this inclined plane. This is some inclined plane, and there is some ball. There is some ball that is placed over here. The ball will roll down, will roll down. The ball will roll down at the bottom over here. Naturally, due to the effect of gravity. Now, you don't need to apply any force to this ball. You don't need to push the ball over here or something. The ball is going to roll down by itself. It is a natural tendency of the universe to bring the ball down from the top of the inclined plane to the bottom of the inclined plane. But is it going to happen that ball will roll upside on its own? No. Okay. First thing. Second thing, suppose there is one pipe over here which is attached to the tank over here filled with water. And there is one container over here. The water will tend to flow out in this container by itself, but water won't flow in. That is again the natural tendency. That is, water always flows from the higher level to lower level. Same applies for gases. Suppose there is there are two chambers. This chamber has some gas over here, and here it is vacuum. Suppose you put or you make some hole. You make some little bit of hole over here, and you made some hole. What will happen is this gas will tend to expand. Why? Because here the pressure is high and here the pressure is zero. This is a vacuum. So the gas will try to expand over here, and the pressure would become such that there is equal pressure on all the walls, on all the side of walls, technically. And that is all about the systems trying to attain equilibrium. Systems always try to attain equilibrium no matter what, be it a water analogy or pressure analogy or this inclined plane thing, or be it electricity or anything. In all the system, substance always tends to move from higher level to lower level. Substance always tends to flow from higher level to lower level. Same applies for heat and heat transfer. Heat always tends to flow from body with a higher temperature to the body with lower temperature. Suppose there is one hot body. Now how can we say that the body is hot? When you touch them, if you feel that it is hot, then it is called hot body. Now that sounds strange, right? but it depends. Now, hotness and coldness are relative measures. Suppose the temperature. So to be precise, I am going to tell you that suppose the temperature of the body is T1, and this is the surrounding area of the body, and the temperature of the surrounding is T2. And if T1 is greater than T2, then body, let us say this body is body A, then body A is hotter than the surrounding. And uh, in this case, heat will be radiated by the body to the surrounding area, and they will keep radiate, and the body will keep radiating this heat till the time that temperature of this body A and temperature of body temperature of surroundings become equal, say T0. So if when both temperature of body A and temperature of the surrounding both becomes equal, then this heat emission process would stop, and the state will be called thermal thermal equilibrium. Okay, now let us start with first law, zeroth law of thermodynamics. Now, zeroth law of thermodynamics basically tells us the direction of the flow of heat. That is, in what direction the heat would flow. Let us say, and there is some body A, and there is some body B. Okay, currently they are placed at some distance. Now we are going to place them next to each other. So this will be body A, and this will be body B. Suppose temperature is TA and the temperature over here is TB, and we are assuming that heat is not radiated to the surrounding area. The heat exchange always is taking place only between these two bodies, and if temperature of TA is greater than temperature TB, then what will happen is heat will radiate from temperature A to B till the time that temperature of body A will be equal to temperature of body B, and they will attain some thermal equilibrium. Okay, now there is some body C. Temperature is Tc, and this also is made to be in thermal equilibrium with body B. So what it actually means is temperature of body A is equal to temperature of body B, and temperature of body B is made to be equal to temperature of body C. That is, these body A and B are in thermal equilibrium, and body A and B are in thermal equilibrium, and body B and C are in thermal equilibrium. So we can conclude that temperature of body B is equal to temperature of body A is equal to temperature of body C. This is what the zeroth law of thermodynamics says. That is, when body A is in equilibrium with another body B, and there is some body C which is in equilibrium with another body B, then A and C are to be in equilibrium with each other. Just to explain you with the help of some diagrams, I'm going to show it to you like this. And there are some three circles, and this is sorry, I'm extremely sorry, yes, this is body A, body B, and body C. Now suppose A and B are in equilibrium, that is, temperature of body A is equal to temperature of body B. B and C are in equilibrium, then in accordance with the zeroth law, temperature A and temperature C should also be equal. And this is all about zeroth law of thermodynamics. And so what we basically learned in this lecture is, first, the natural tendency of the system to undergo the stability and tend to reach its equilibrium state. Then we saw various examples about water analogy and roll down on inclination plane and vacuum gas, etc. And then we saw everything flows from higher level to lower level. And then we saw the concept of thermal equilibrium and the relative hotness and coldness. Again, remember, hotness and coldness are always relative, because it really depends on the temperature of two bodies. Like say, uh, you can't say that something is hot and cold absolutely. uh, and then we saw the real thing, that is zeroth law of thermodynamics, which is basically a law that tells us that in what direction heat flow would occur. And that is it. That is all about zeroth law of thermodynamics. Thank you.